cards, that could take almost an hour where you would want to be sleeping, right? And every once in a while I have complete memory lapses, right, where I don't remember what card I backed up and what has happened. So that's why this workflow and software together, they form a very solid workflow. So you need these things together. Any questions about this? No? No. Alright, so I'm going to go, this stuff is very basic, but I'm just going to go over your basic storage solutions, right, very, very quickly, because this is not the most important part, right, because everyone's sort of aware of this. Alright, so your normal spinning mechanical hard drives, they have like spinning disks inside them. These are great for bulk storage, mostly because the cost per TB or the cost per GB is very low, right? So you can get, I checked recently, you could get a 3 or 4 TB internal for something like 6,000 or 7,000. Somewhere in that ballpark you will get one. Okay, but they're relatively slow, mostly because now 7200 RPM drives, the faster big hard drives are on the way. You don't get them, you get them, but they're not as popular. You normally get 200 RPM hard drives, 5400 RPM hard drives. Okay, that's relatively slow, reasonably reliable, relatively slow compared to other storage solutions. Okay? They have a limited time to live, so they will fail, and they are going to fail often, and it is going to happen, right? And when it happens, it will almost always be catastrophic. It will be a big problem. It won't be a small one. And the reason why problems with big hard drives tend to be more catastrophic is because you're storing more data, right? You basically have all your eggs in one basket, right? And when that big basket goes boom, you lose everything in one shot, right? It's not like you lose granularly, you won't lose half of it, you lose most of it in one shot. So this is what I do, prepare for a 1-year replacement cycle for hard drives. This is because I'm specifically paranoid. And I've seen very funny things happen with hard drives. So I actually, when I archive my photos, which is your long-term storage thing, I actually have separate, any hard drive of mine which is older than 1 year becomes an archival drive. Right, so basically on my desk I have sitting a stack of hard drives, not in my desk, they're in my drawer now, but the stack of hard drives is an archive of my old photos, and that's it. It's just, they're never plugged in. All the data was copied onto them and they were sitting. Very recently, because of this protection workshop, a couple of weeks ago, I decided to bring them up online just to see what had happened. Right, 2 out of 3 refused to start, and they were just sitting on my desk. The newest one did, the oldest one was 4 years old, that one did. Right? And the one after that, I could copy data of it, but then it went kaput after that. Right? So just drives just sitting in a drawer can go bad, right? For whatever reason. So don't really trust them. I use a 1-year replacement cycle. I have dates written on my hard drives when I purchase them, and I have a reminder in my calendar. Right? So this is the hard drive. On this date, I'll get a reminder that this hard drive should become, from a live hard drive, should become an archival drive. It shouldn't be trusted anymore with data. Generally, hard drives, there was a company called Backblaze, which is a data center company. They did a lot of research. They did a check about all their hard drives, and they found that most hard drives will not last more than 3 years. That's of course in a data center environment. It's much more rough on hard drives, but in general, I would say 3 years is a good number. Right? I do 1 year, but you guys can pick what you want. And now it doesn't cost that much. I mean, one lens will cover you for hard drives for the next 2 or 3 years. Right? How much you spend on one lens. Right, so this is what you get. You have the Chota bus-driven hard drives. Right, these are the USB 3 bus-driven hard drives, which are great for travel. Your regular internal hard drives and the big powered desktop hard drives. Okay, so SSDs. They're very fast, generally very reliable, extremely expensive. So right now in India, Samsung 840 Pro goes for about 120 GB, goes for about 7,000. 6 to 7,000, right? That's about how expensive they are. So you're basically getting an order of magnitude less data than a regular hard drive, right? Much less data. They're far more reliable in mechanical drives simply because mechanical impact makes no difference to them, right? You can bang them, you can do whatever you want to them, and it makes no difference to these hard drives. These are perfect. They're perfect for storing catalog files and Photoshop scratch tests. The reason is, this is out of experimentation. I realized that it literally makes no difference where the Lightroom raw files are for an export. The Lightroom raw files, the location doesn't make much of a difference. The catalog file makes a huge difference. The catalog file should not reside on the same drive as the raw files. If it does, then you get performance issues. So your Lightroom catalog file should always be on the fastest drive that you have. For most of them, it will be internal storage on your laptop. And if you have an SSD, put it on the SSD. That will make a tremendous difference. Ideally, in a perfect world, you want the RAWs and the catalog files on two separate SSDs. That would be the best possible solution, but it's also extremely expensive, right? So in this case, what I do is I have an SSD in my machine, I have a second SSD, and I have other storage also. So when I'm working on a job and I want to get through it quickly, I move the RAW files onto the working SSD. I have the catalog files on another SSD, and I work that way, right? So if you want quick access, want to work on data rapidly, and you want good responsiveness from your system, this is what you should be doing. Right? And it makes a huge difference. And this is what they look like. Right? Good brands, the Samsung 840 is considered to be like very, very good. Intel is supposed to be very good. Is there anything else?
Crucial.
Crucial?
Yeah.
Okay.
Very cheap and good.
So these are good SSD brands if you want to buy one. Again, I would buy more than you think you need. Right? So everyone gets terrified about SSD prices, and they tend to buy the smaller capacity ones. Just buy the most you can at one shot. It's better than having to buy it and replace it again, because you will have to do that. Okay. Any questions? No? Okay. Next is network storage. Network storage, by that I'm talking about NAS devices. I'm not talking about SAN devices, because that's enterprise level stuff. No one is going to do it. Right? So NAS devices are basically, let me describe what a NAS device is before I get to this. It's basically a storage device which is sitting, which you can only interface with or only access via the network, via a network, a LAN, a local area network, or a WAN. But it has to be sitting on a network. You cannot directly connect to it. You cannot put USB on it. You cannot connect via USB. You cannot connect via eSAT and nothing. None of those things work. It has to go straight over the network. That's the definition of a network attached storage type. Okay, so they're usually quite slow. The speed is dictated by the speed of your network. Even if you're running a gigabit Ethernet network, it's not going to be faster than plugging in a drive, an SSD especially. Right? There are a large range of products. They go from cheap, you can get reasonably cheap ones, to very expensive ones. The very expensive ones are like Drobo and such. Most products include RAID capabilities and multi-drive mounting. Right? I'll show you what that means. And they're great for online archival. By online, I don't mean internet archival. By online, I mean, so there are two different kinds of storage. There's offline and online. By online, the distinction is online storage is available whenever you want it. You don't have to plug in anything. Offline is something which needs to be plugged in to access. It needs human intervention to access. Right? Online archival, these things are ideal for online archival, because you're not going to access them that much, because you don't need speed. Right? So these are some examples. And Drobo is, lots of photographers use this. I think it's colossally overpriced for what it is. Right? But it's basically, you can insert drives into it, and it will form a drive array for you, a RAID array. That's something like what I have. I have a 2-bay version of that Netgear thing. Right? So you can insert drives in, and those drives will come up on, they will show up on your network as a shared drive. Like if you've done internet file, if you've done local area file sharing between computers, it looks like that. Most of these guys have RAID capabilities, so you can plug them in and configure a RAID. You can do RAID 1, RAID 0, RAID 1, all the way to RAID 5, 5+1. Right? So you can do different RAID modes. My recommendation is, if you have one, and I don't think most of you are aware of RAID, but RAID is basically using multiple drives for redundancy. It's a redundant array of inexpensive drives. Inexpensive may or may not be true. Right? So the idea is you can plug in drives, and each drive will act as like a backup for the other one. Right? That's the idea. RAID 0 is the only one which doesn't fit that paradigm. RAID 0 is 2 drives are there, and bits are written alternately to those drives. It's called striping. Stripes of data are written alternately. So when you read, it's reading off 2 drives. So it's much faster when you read. Right? The obvious problem with RAID 0 is half the data is here, half the data is here. Half a file is here, half a file is here. So if one goes bad, you lose everything. Right? And we already know hard drives are unreliable. So you're basically multiplying the chances of data failure if you use a RAID 0. I used RAID 0 once, never again. Right? And I used RAID, it was my mistake, I used RAID 0 with what was considered to be the most unreliable hard drive of that time. It was called the IBM Desk Star. It was so unreliable, they would call the drive the Death Star, because it was going to fail. It was just a matter of time. The only redeeming feature of that drive was, at that point, it was the fastest drive anyone had. So I thought, chalo, I'll get it even faster. One day, one drive went down, and I lost all my data at one shot. Luckily, in those days, I was not shooting photographs, okay? So it didn't matter to me. So what I prefer to use is RAID 1. not the more complicated RAID 5 or anything. I use RAID 1 for a very simple reason. RAID 1 is an exact mirror. So if one drive is in there and the other drive is there, and you get RAID 1 mirroring, which is this drive will be identical to this drive no matter what, right? Now the problem with this strategy is you're going to lose half your storage straight away, right? So if you put 2 3TB drives, you basically only have 1 3TB drive, but with proper consistent backup, no problem. Now the reason why I use RAID 1 is if something happens to one drive, all I have to do is remove that drive and this other drive will still be working, right? And if I want to make a backup again, I just replace this drive with a fresh drive, put it back in, let it rebuild the array, and you get backup again, and you're up and running. So you're never interrupted for a rebuild or any kind of recovery. You just pull out the drive and you're still live. You still can keep going, right? So that's why I like RAID 1. It's obviously expensive in terms of data, but it works really well for this kind of stuff. So I have 2 drives. I have 2 3TB drives running, and my archival. This is my archival box. I have 2 3TB drives running in RAID 1. So that's how I work. Synology is also a very good company. Netgear is also decent, and there's also little benefits of buying one of these things. Like the Netgear one, most of these things can even do torrents for you. You can run torrents on that. You can do all sorts of very interesting things. You can make a local cloud. You can make a cloud, a private cloud for yourself. Lots of little interesting things you can do with one of these. Of course, you could make one. You could make one of these with spare PC parts, but the benefit of buying one of these is the power consumption is pretty low. Right? So it's a specialized device. Any questions? No? Okay.
The online storage you talked about is internal